Alright, so we're going to continue today with simplifying square roots, cube roots, and fourth roots. So first up here, I think one thing that's good to do in all these problems is just take each term individually. We have our coefficient here of 49. We have our x term, we have our y term. So square root of 49, not too bad, it's a perfect square, it's just 7. Then the square root of x to the 6th, remember we're going to divide that exponent by 2. It's always the power divided by the root. So 6 divided by 2, that works out nice. And the only one that doesn't work out nice here is the y to the 9th. It's going to be y to the 9 divided by 2. So 2 goes into 9 4 whole times, and you have 1 left over. So to put our final answer together then, we have 7 x to the 3rd, y to the 4th, and then we always put our radical last. So square root of y on the end then. Okay, so next up here then we're going to do the same thing. Square root of 75. Not a perfect square, but we can break it into a perfect square. 25 square root 3. Square root of 25 is 5. So we get 5 root 3. X to the 5th. Square root of x to the 5th, so it's going to be x to the 5 divided by 2. So 2 goes into 5 2 whole times, and you have 1 left over. My y's, square root of y to the 10th. I'm going to get y to the 10 divided by 2. So y to the 5th. So for my final answer then, we're going to have 5x squared, y to the 5th, and then I'll put my radicals. I have a square root of 3, square root of x. And that's my final answer then. Alright, so moving on to cube roots. Again, always make sure you look at the root first because that changes a lot with every problem here. So first up, we got the cube root of 64. Nice and easy, it's just 4. 4 times 4 times 4, 64. Then we have the cube root of x to the 6th. So it's going to be x to the 6th divided by 3 is x squared. And then the cube root of y to the 7th is going to be y to the 7 divided by 3. So 3 goes into 7 2 whole times, so it's going to give me y squared. And I got 1 left over, so I got a cube root of y left. So we're going to go 4x squared, y squared, and then just a cube root of y on the end. Alright, number 4 then, we have the cube root of 81, x to the 5th, y to the 12th. So my cube root of 81. 81 is not a perfect cube, but we can break this into the cube root of 27 times the cube root of 3. So the cube root of 27 is 3. So I get 3 cube root of 3. X's, I have the cube root of x to the 5th. So it's going to be x to the 5/3. So 3 goes into 5 1 whole time. And then I have a remainder of 2. So I have an x squared in the radical there. The y turns out a little bit nicer because I can do 12 divided by 3, get y to the 4th. So 3x y to the 4th. I do use all of my non-radicals first, and then I do the cube roots, 3x squared. Okay, and last up we have a fourth root. Fourth root of 625 is 5. And then we have x to the 8 divided by 4 is going to be x squared. And then y to the 10 divided by 4. 4 goes into 10 2 whole times. So it's going to be y squared. And then we'll have the fourth root, we had a remainder of 2. But with this fourth root of x squared right here, it's going to be x to the 2/4, which is x to the 1/2. So I'm just going to write it as a square root of x on the end then. Alright, so final answer 5x squared, y squared, times the square root of y. Sorry, these should be y's here. I don't know why I changed that to an x. Okay. So a couple practice problems today. You do not need to send me your answers. Today's just a practice day. Have a good day. Bye.